add these two, that kills B, so I get that A is 1/2 C plus D, or it's actually C0 over 2 e to the minus I omega 0, sorry, omega CT plus D0 over 2 e to the minus I omega DT. And then if I subtract these two, I kill A and I get 2B. So B is 1/2 C minus D. So this is C0 over 2 e to the minus I omega CT minus D0 over 2 e to the minus I So then A of t is, I can absorb this 1/2 into the constant, so I just don't need to worry about it. So I'm gonna just put this alpha e to the minus I. I will have E0 plus B0 over h bar t plus beta e to the minus I E0 minus D0 over h bar t and B of t. Now, if I'm calling this coefficient alpha, then I need to call this one alpha too, right? So this is alpha e to the minus I E0 plus B0 over h bar t minus beta e to the minus I E0 minus B0 over h bar t. And I don't know if you remember from before, but these are also actually eigenvectors, so I'll have to talk. So, and I can write this in a neat way. A of t, there is a common prefactor for both, right? So this is e to the minus I E0 t over h bar, and then there is alpha e to the minus I E0 h bar t plus beta e to the I B0 h bar t. And B of t is e to the minus I E0 t over h bar, and then I will have alpha e to the minus I B0 h bar t minus beta e to the I B0 t. So far we are good, right? And then the arbitrary state psi of t, which we wrote as A of t, B of t, is just this state. So this is e to the minus I E0 t over h bar. And then we will have alpha e to the I B0 t over h bar plus beta what it looks like. So I can split this up into two pieces. So I will have alpha e to the minus I p0 t over h bar. And then I will have 1, 1 here, right? So if I haven't made that I think I did this right? Algebra. And now you have your choice. If you want to express this state in terms of z basis, this 1, 1 is what? Is 1, 0 plus 0, 1. So this is up z plus down z. Or you can write it as square root of 2 times up in x or if you want to be a little bit more laborious, so you're going to put I 1, 1 is 1 to express it in terms of the y basis, I need to do some work. So 1i, 1 over square root of 2 is 1, 0. Because of this darn I, it's a little bit more complicated. And then we use this 1, 0 as I think 1 over square root of 2, 1, 1, right? So if you combine it here into the first one, so 1 over square root of 2, 1i is 1 over square root of 2. Instead of 1, 0, I have to write 1 over square root of 2. This would be up in the x direction plus 1 over square root of 2. Down in the x direction. And then I have to repeat the same thing for the other one. And then I have to express the other one, so I will have it in terms of x direction and y. So you can express basically x in terms of y. This is something what I didn't do. So this is your homework problem. Okay, you see these traits? I have expressed z states in terms of the x states. Z states in terms of the x states. And here I have x states in terms of the z states. Now, you need to find a way to express z states in terms of the y states and y states in terms of the z states, and then find expression for the y states in terms of the x states and x states in terms of the y states. It's just a linear algebra, which is pain in the royal end, but just do it for the sake of the exercise. It's not so much quantum mechanics as it is linear algebra, but result is what is applicable to quantum mechanics. So that's all you need to do.
And then you said y states in terms of x
States and x states in terms of y states. So basically all combinations. Z, x, x, z. Z, y, y, z, x to y, y to x.
Because that looks very similar to like a hyperbolic function. There's no infinity that
I suppose you could because it's alpha squared plus beta squared is equal to 1.
Okay.
So these are more like sines and cosines.
Okay.
So you can express them any way you want. It really doesn't matter. You may as well keep them in a matrix form. I don't know if Griffiths has that in his book, but if he does, he probably made a rocket science out of it. I know that McIntyre, which is the book that I think this is a popular textbook because my son who is at Fullerton, he also taking quantum mechanics that was there. And some of you may have come across McIntyre book of quantum mechanics. I know for sure that in that textbook, this was made into a rocket science at the level of SpaceX, landing the rocket back on a platform on a sea.
This?
The whole thing, yeah. I think he has like 3 chapters in the book. In any case, so we have these states, and so psi of t. I never understood this business. So we have psi of t, which is basically, I'm just gonna keep it in a matrix form because I really don't care how do you express them in the intermediate step. It is for finding the answer that things matter and that you can find without all this sunken ends. So it's e to the minus I e0 t over h bar, and then you have alpha e to the I v0 t over h bar minus beta e to the I v0 t h bar and alpha e to the minus I v0 t h bar minus beta over h bar. Okay, that's all I need. Now, to answer our original question, if we prepare the state initially to be the state with the spin in the z direction, what is the chance that at some unspecified later time that state has spin in the positive x direction? This is how we do it. So from the statement that at t equals 0, psi of 0 is this. Which means that at t equals 0, I have this as a state. So, what do? You stick t equals 0 into that equation, right? So psi of 0, once you have the solution, this becomes 1, all these exponents become 1, and then you end up with alpha plus beta and alpha minus beta, right? Is 1, 0. So this gives you 2 equations where alpha plus beta is 1 and alpha minus beta is 0. didn't screw up this with the heavy answer that alpha is 1/2, right? And beta is 1/2.
No, suppose beta is 1, not 0. That's
Oh yeah. 1. So this will be alpha and beta are the same. So this is 2 alpha equals 1 and 2 beta equals 1. So they're the same.
it's 90.
Huh?
It's 90 speed now.
Okay. So what this means basically, this initial condition will uniquely determine alpha and beta. Everything is already normalized, so it will work. And then at a later time, since a later time, at some time t, we want to have the state which is up in the x direction. So this is the state which is 1 over square root of 2, 1, 1, right? So if this is what you want to measure, then you actually just do the multiplication. And pick out the coefficients. And that will give you the probabilities. They will depend on time. So we'll do that next time. And I really personally dislike when this is broken down into pieces because it basically becomes a tongue, or mouthful. Because there are too many verbs being used for which are unnecessary. Because the question tells you what you need to specify at the beginning and what you want to measure later. What it looks like in between, nobody cares.